All right, guys, adding on a couple skills, what we learned today about imaginary and complex numbers. Okay, this is going to be a video that is about, whoops, I got to get my pen out here, sorry. That's going to be about the absolute value of complex numbers. Okay, let's talk about what the absolute value of a real number means. Now, a lot of people know that absolute value really just makes every number positive. Okay, so the absolute value of 8, of course, is 8. The absolute value of -5, okay, is 5. It just takes any number and makes it positive, whether it's positive or negative. Well, that's because the actual definition of absolute value is distance from 0 on a number line. Okay, so if I draw a quick number line here and I put 0 in the middle, 1, 2, 3, 4, 5, 6, 7, 8. 8 is 1, 2, 3, 4, 5, 6, 7, 8 units away from 0 on a number line. Okay, so its absolute value is 8. -5 is, again, 1, 2, 3, 4, 5 spaces or units away from 0 on a number line. See, distance can never be negative. That's why the absolute value is always positive. The absolute value can never be negative because distance can't be negative. Even in real life, like if you're saying that you're traveling to Florida, you're not going to say, I'm going to go -700 miles just because you're going south from Ohio to get to Florida. You still say I'm going 700 miles. If you dug a 6-foot deep hole, you wouldn't say I dug -6 feet. You'd say I dug a hole 6 feet deep. Distance is positive. Okay. So what absolute value of a complex number is distance to 0. Okay. But 0 happens to be the origin. Okay, and what I mean by the origin is that you're finding absolute value on what's called the real and imaginary axis. Okay, your x-axis is your real axis, and your y-axis is your imaginary axis, and you're going to find the distance that a complex number is from the origin on this axis. Okay, I'll put in a couple tick marks here for us so we can get through this problem. So let's say I gave you the complex number 2 minus 4i. Okay, well, let's plot that on my real imaginary axis. That's 2 on the real axis, -4 on the imaginary axis. That's right here. So I want to know this distance, the distance from the origin, the blue line. In order to do that, what I instantly see right now with my just kind of thinking of a mathematical or geometry brain is a right triangle here, where the blue line is the hypotenuse. Okay, the triangle here has side lengths of 2 and of 4. So now I'm just going to use the Pythagorean theorem, a squared plus b squared equals c squared. Okay, so I would have 2 squared plus 4 squared equals the blue line, which we're calling c squared. That'd be 4 plus 16 equals c squared. Okay, that's 20 equals c squared. So c, or my blue line, is the absolute value of 20. That would be the absolute value of 2 minus 4i I just found to be the square root of 20. Okay? Now, I can think of that. You can always think of it like that. Okay? And I'm perfectly fine. That's how I think about it. Come on now. Come on now. That's always how I think about it, is drawing a triangle. Okay? If you'd like a formula, okay, remember that imaginary numbers come to you in the form A plus BI. Okay, the formula is that the absolute value of A plus BI of any complex number is just the square root of A squared plus B squared. So if I said, what is the absolute value of -6 plus 4i? Okay, that would be the absolute value of, anytime you square something in your calculator, put it in parentheses, -6 squared plus 4 squared. That would be the absolute value of 36 plus 16, which is the absolute value of 52. That would be its absolute value. Okay, so think of it either way. Put it on a graph and make a right triangle and do the Pythagorean theorem, or memorize this formula. That is the absolute value of a complex number. All right, there's going to be another video after this. So I'll see you in class. So watch the next one too.